Okay, so today's session, we'll be discussing on, of course, NoSQL, CosmosDB, the native Azure NoSQL database. I mean, we usually call it as like globally distributed mission critical database. So that's the tag it has got. But before going there, or before starting that, let's have the quiz on data lake so that, we have a better understanding on where we are, how much we understood, and how that is relevant to the exam or the certification point of view. What we'll do is, I've got a couple of questions. I don't really think I've covered all the questions, but I have taken like few questions from the set because, due to time constraint, we cannot really manage all of them. What we'll do is I've also added headings there, like this question is from this topic, so on and so forth. So I'll read out the question. I'll put the question on the screen. You'll also see the options there. And I think we have added the option called polls in Zoom. So I'll be launching that, and yeah, you'll be given some time. So do not worry, do not hesitate, do not feel bad if you don't know the answer. Just share your opinion, right? There is nothing called wrong answer. We will try to refine it. So that's how you learn. But please, I want everyone to poll your answers, right? Either right or wrong, doesn't really matter. Just poll your answers. Just try to think, because the real questions might be a little bit tricky and difficult. And we have the similar real questions from the previous exams, so that you know the level of difficulty you're going to get in the exam, if at all, if you're trying to, or if you're giving certification. Because I know most of you also wanted to upskill yourself, but few of you wanted to do certification. Anyway. Let me zoom it out. Okay. So I have enabled the poll. Let me start with the first question. Okay, so let's start this. So I think you're able to see the screen, right? So the first question, this is again, all these questions are on data lake. So don't worry, we have already covered these sessions and these topics. So the first question is, you have an Azure data lake storage Gen 2, we know that, and it's a container, right? So data is ingested into the container. Of course, you can read your question. I'll just read it out loud once. Data is ingested into the container and then transformed by a data integration application. Okay, so data integration, we have not gone there because we know data factory is a data integration, but for now, just assume that we have a data integration application. So the data, let me take this laser. The data is not modified after that. Users can read files in the container, okay, but cannot modify the files. Okay, that's a statement. So you need to design a data archiving solution that meets the following requirements. So they are asking us to design some archiving solution with the list of requirements. So the first one is, new data is accessed frequently and must be available as quickly as possible. We know what it is. The second one is, data that is older than 5 years is accessed infrequently, but must be available within 1 second when requested. And the third one is, data that is older than 7 years is not accessed. After 7 years, the data must be persisted at the lowest cost possible. And the fourth one is, cost must be minimized while maintaining the required availability. So how should you manage the 7-year-old data? So out of these requests, he's asking on the third request. He's asking on this one. The data that is older than 7 years is not accessed, right? So how should you manage the data, 7-year-old data? So I'm launching the poll. So the available options: delete the blob, move to archive, move to hot, move to cool storage. So please let me know that you're able to see the poll option. I think it should be popping up on your screen. Perfect, perfect. So just give your answers, right? I hope everyone is done, because this is pretty straightforward and there is nothing difficulty in this. So again, the question is same. Here, they're asking different one. So how should you manage 5-year-old data? So they're asking about this one. Data that is older than 5 years is accessed infrequently, but must be available within 1 second, guys. So this is the thing which you need to focus here. I'm not sure if someone is accessing this. Okay, when requested. So again, you have the same options. Question 3, guys. Pay your attention here. So you see, sometimes you might get a question which is like 2 or 3 pages, but do not worry if you understand the question. So it will be very easy for you. So these kind of questions, these are like series of questions, right? So the thing with these kind of questions is you get a question and you submit one answer and you cannot come back to review and change the answer. So you might get these kind of questions. These are like series questions. That's what we call. And once you submit the answer, you cannot come back. So before submitting the answer, you need to be very careful. And just to give you a very high level introduction, I've also added these kind of questions. So you have to read question carefully and you submit either yes or no, then you get like a couple of options. I mean, like a couple of similar options with a similar different options to select the answer. So your company is creating an e-commerce website where different vendors can sell their products. Okay. E-commerce website. Okay. These products can have same or different attributes. Okay. For example, first vendor can have product name as bicycle, which contains attributes like price, description, brand, part number, and size. Okay. And another vendor with same product as bicycle have attributes like price, description, weight, and model. So if you see here, you have like two different attributes. For the first attribute, you have different list. For the second attribute, you have different lists. So as a database engineer, you need to design a data solution that can accommodate with product attributes for same product. Okay. So here the product table is same, but the contents are different. The columns are different. Okay. Just try to focus here. So you should also be able to query product data using .NET. Okay. So do you think, here's the question. If you create a table storage account, it will meet the goal of the solution. We have discussed what is table storage, right? Table storage within Azure storage. You have 4 different types: blob, table, queue, right? So within that, he's asking that if you opt for table storage, will this accommodate? What is table storage? Table storage is a NoSQL, key value pairs. So you don't really have a schema for that. I mean, that is what it is. So I think if the answer is yes, press yes. If it is no, press no. I'm moving to the next question. Okay, perfect. Here, the question is based on the security. We have discussed a security topic. So you are working as a data engineer for your company that has an Azure SQL database and an Azure Blob storage. We know what is Azure SQL database. We know what is Azure Blob storage. Now, the company has given you the task to encrypt the data at rest. So they are talking about encryption on both the systems. Also, the company should be able to use their own key. Oh, we discussed this. We can also use our own key using Azure Key Vault, right? We discussed this. You have 2. One is Microsoft managed, the other one is customer managed. What should you be using to configure security for the Azure Blob storage account? So you've got like Azure Disk Encryption, Secure TLS, Transport Layer Security, Azure Storage Account Key, and then you have Default Storage Service Encryption. This question is kind of tricky and you need to, just think out of box, but you have the answer. We have discussed about the answer as well. I'll give you like 5 more seconds just to, go through the question and think and keep your answer ready. Okay, moving forward. Again, another question on security, right? So you're working as a data engineer for a company that has Azure Data Lake Storage account. You see Azure Data Lake Storage account. This is something we already are familiar with. They have decided to implement role-based access control. Okay, we know what is RBAC. We have discussed role-based access control in yesterday's class. So that project members can manage the Azure Data Lake storage resources. Okay, so they wanted to create RBAC for their Active Directory, the users. Okay. What action should you be doing for this? Select 3 options from options given below. So there are few questions which you might get, which are like multiple options. So you have like different square boxes where you need to check, right? So in this question is asking to select 3 options from the given list. So which 3 options can fulfill the requirement of role-based access control? What you need to do? What are the steps you need to follow? Let me read out the answers. I think this is also very easy. Don't get confused here. The first option, what he's saying is ensure to assign Azure AD security group to Azure Data Lake storage. So he's asking that create a security group. We discussed what are groups. He's asking to create a security group because here they are giving project members. They are not talking about individual users. They're talking about group of members. So maybe groups can be part of the answer. I'm not sure. Think, right? So first thing is ensure to Azure AD security groups to Azure Data Lake storage. The second one is Make sure to configure end user authentication to the Azure Data Lake storage account. And the third option is make sure to configure service to service authentication to the Azure Data Lake storage account. And the fourth one is create security groups in Azure AD and then add project members. Okay. And the fifth one is configure access control lists for the Azure Data Lake storage account. I'm not really sure if you have given multiple options to select in the poll, but at least keep in mind that you have got like 3 options for this. To make this answer correct, you need to select 3. Okay. Which 3 options you can use to create role-based access control here? Okay, moving forward. Boy, this is a question on redundancy. But if you see, the question is kinda 2 pages. But no surprises because you will get questions similar to this. Don't worry. We will try to understand, because this is like a scenario, right? When you're discussing with your team members, when you're discussing with your manager or your end user, they might come up with these kind of use cases scenarios. You being a data engineer, they'll explain you all this use cases list. You see, I want this requirement, and finally give me a solution based on your Azure expertise being as a data engineer. So that's the reason these are called like case study questions when it comes to Azure certification. So you might get 1 or 2 case study questions. So this is one of those case study question. I'll quickly go through this, try to grasp the important information within this whole question, right? A food delivery organization known as Food Corp, okay, has globally distributed applications. Okay. The data solutions provided by Food Corps utilize the following Azure products specialized for data. Okay. Azure Blob storage for storing and tracking status. Okay. Azure CosmosDB. We are going to discuss what is CosmosDB in today's class. For storing customer orders, data regarding the customer and restaurant, right? Like, address and menu. And they have Azure SQL database, Elastic Pool. Lakshya's explained what is Elastic Pool, what is Azure SQL database, to be utilized by internal company systems. Okay. Here, the requirements. The platform should be adaptable and flexible enough. I wish it was that well documented, and I wish it was that well documented and explained. Sorry, I didn't get your question, please, from the chat. Okay. In real life, just a comment on what you said. Yeah, true. But usually, whichever training you follow, usually they don't really go in this depth, because even Azure trainings don't provide in this level. But being this comes with an experience, right? This actually comes with an experience. Being a data engineer, having tons of experience, then you try to think in that direction. Okay, so requirements: the platform should be adaptable and flexible enough to deal with service failure or breakdown. So they are giving their requirement. Of course, everyone wants this, like, it has to deal with service failure and breakdown. If it happens, that affects one of the availability zones within Azure region. Okay. A secure mobile application access needs to be provided to the database that stores customer orders, which is hosted in the Cosmos DB. Okay. The application must be able to read and write queries straight to the database that stores customer orders. The Elastic Pool store the 15 configured data. In Elastic Pool, they have stored 15 databases, guys. See, usually in real time, you'll have like 15, 20, 30 used by internal systems. In case of service failure of breakdown in Azure availability region, the internal system databases should be in readable format. So what they're saying is, in case of failure, right, of Azure, any of the region, we discussed what is this region failure. They want the secondary region to be up and running so that the internal system can read the data directly from the secondary system. Okay. Okay, so a new external partner of Food Corps must be provided when deploying in a new region that has the read access to directly view the tracking order history saved in the Azure Blob storage. The external partner must also not have unlimited access to Food Corps, and the access should be automated to expire after 2 months. This rings some bell, right? There are orders database. This is orders database. The orders database caused a blockage in the course of reading the orders collection in the database during the marketing campaign of a preceding regional launch. The throughput, we are going to discuss what is throughput in CosmosDB. The request units DB had to be increased for the purpose of eliminating the blockage. No change was done to other collections having a throughput different from throughput processed by orders collection. Internal systems. So they are giving like different systems. This is orders database, internal system database, their requirement. Okay. An administrative task needs to be executed daily on the database present in the system. This task is a PowerShell script. Okay. In a very high level, we got some information about what they want. Okay. Very high level at least. This is the question, guys. You have been given a task to implement the redundancy strategy. Redundancy strategy. Just highlight this. For order tracking status storage to meet the appropriate requirements. The costs should have to be kept as minimum as possible. I think I told in the yesterday's session, we discussed about redundancy techniques for Azure storage. We have like what, 6, right? Out of 6, we have like 3 main. And to keep the cost minimum and also to have a high availability, there is one option I told you. What data redundancy strategy and storage account type should you be using? Select the relevant options. So from this option, data redundancy, they're asking to select either one of this and storage account, either one of this. Okay. So you have to select like 1, 2, 3, 4, either A or D or B or E or C or E or C or D. Okay. So here the main outcome or the main thing which we need to keep in our mind is this is about redundancy strategy. And this is like, they're asking to keep the cost as minimum as possible. So with these concepts, you need to come up with the solution. Okay. And also storage type. So which storage type will you select? Will it be like a general purpose or will it be like a blog storage account? Yeah. Just try to like, just use some sort of common sense as well, because this is like kind of tricky, but not that tricky, straightforward as well. Going to the next question. Okay, this is very small. Thank God. Okay, this question is from monitoring, guys. We've discussed monitoring services, Azure Monitor yesterday, right? So you're working as a data engineer for a company that make use of Azure Data Lake Gen 2 storage account. Okay. They want it to be used to store big data related to an application. We know why we use data lake. We use that to store big data. Your company now wants to implement logging. Okay. They're asking you to enable the logging mechanism. Okay. Again, this is series-based questions, right? Once you click or submit an answer, you cannot come back to that. So here the question is, after discussion, okay, you had like your internal workshops and discussions within the team. They decided to create an Azure automation runbook, which would be used to copy events. Do you think this would fulfill the requirement? So the requirement is to implement logging, and they're giving you an option that Azure automation runbook. Will this help you to do logging for data lake? If it is yes, yes. If it is no, no. Okay, straightforward. I think I have a series of questions on this, I believe. Okay, question 2. So here the question is still the same. They're asking, after discussion, they decided to use Azure Active Directory reports. Will Azure Active Directory reports help you logging? I'm not sure, but if it is yes, then yes. If it is no, then no. Okay. Moving forward. After discussion, decide to configure Azure Data Lake Storage Diagnostics. This looks something familiar. Anyway, Data Lake Storage Diagnostics to store the logs and metric data in storage account. Yeah. So do you think this would fulfill the requirement? If it is yes, yes, or else no. Okay. I think that's it. Again, these are like very small set of questions. I think maybe I can end the poll now, right? I hope everyone submitted their answers. End polling. Okay, share results. First question, I think it's very straightforward, right? 7 years data, it's archive. You should move it to archive. Yeah. Okay, someone said it cold storage, but it's not actually cold, it's archive. Yeah, because here they are saying, if you try to, after 7 years, the data must be persisted at the lowest, because archive is the lowest one, right? Out of hot, cool, and archive. But I'm not sure why you selected cool, because they mentioned that for infrequently accessed data, we usually use cool for infrequently accessed data, but if you wanted to access, that will be available within seconds. But when it comes to archive, it's not, because you have to do a process called rehydration. You have 2 different types, standard priority, high priority. It takes hours based on the availability, right? So the answer is archive. Really good. Perfect. You guys are following. So our efforts are not really wasted here then. Next question. How should you manage the 5-year-old data? Yeah, 5-year-old data, because they also wanted to access it within seconds. Then the answer is cool. Cool storage. Yeah, I think majority has given cool storage. See, I think someone has selected hot. That's fine. Kind of tricky, but I understand. So data that is older than 5 years is accessed infrequently. When they say infrequently, you should forget about hot, because frequently, hot, those terms are kind of related. So it's cool storage. Someone selected delete the blob. How should you manage 5-year-old data? No, you don't delete the blob. They want it, right? They said like must be available within 1 second. If you delete the blob, that's not available, right? So, okay, here. Perfect. Most of you got the answer correct. The answer for this is yes, table storage, because in table storage, the way we store the data, because it is a schema-less, right? So you don't really have a schema, so you don't define the columns, right? And here in the question, they mentioned that, for attributes, you have different items or different columns here. For bicycle, you have from one vendor, you have price description. From another vendor, if you see, here you have brand, here you have weight, right? So these are two different columns. So in those scenarios, we leverage table storage because this is NoSQL design. Most of you got it right. Security question. You're working as a data engineer. Okay, so the answer for this is storage keys. Answer is 3 security storage keys. Okay, majority of you got storage keys. I understand some of you had opted for default storage service encryption. If they wouldn't have given, maybe use their own key, I would have said this, but you have to eliminate. You also have to come up with an elimination process here. Descriptive encryption is not an answer. Secure TLS, I don't really think this is an answer. Default storage, yes, but the thing is they asked to use your own key. For default storage encryption, we don't use our own keys. Microsoft has its own key. So if they would have given like Azure keyword or something, maybe I would have opted for it. But within this list, the reasonable answer for me is storage account keys. Okay. Moving forward. So here, security questions, multiple choice. Yeah, ensure to assign this, create security groups, configure access. So here, guys, what you need to do here is, just a quick second. Cool can be accessed within 1 second, but at higher cost. Yes, correct. Here, first, the correct answers, I'm putting them here. This one, this one, this one. So you need to create security groups and add the project members, assign that group to Azure Data Lake storage, and configure the access control list. So that's the order. Where is my poll? Okay, the big question. Eh? Okay, so the answer for this question is very simple. So it's zone redundant, C, and the general purpose V2, E, C and E. Whoever selected option 3 is correct. But it's really good. Majority has gone for C and E. That's nice. Monitoring question. Yeah, Azure Automation Runbook. No. For logs, you don't go for Azure Automation Runbook. I mean, we have diagnostics. Yeah, majority of you have given us no. That's correct. Of course, Azure Active Directory, I don't really understand because this is like out of scope. See, these kind of tricky questions you might get. We've never seen that, but that's an option. Oh. And again, what is the other one? Yeah, for the last question, the answer is yes, correct. Diagnostics. We have gone through this, right? In yesterday's class, diagnostics are really used for us to see those logging of those metrics, logs and metrics. You can use diagnostics. for the redundancy question, why not use geo redundancy? Good question. The reason why we haven't used geo redundancy, because they want us to keep the cost as minimum as possible. Because if you go for geo, the price in the geo is really high, right? And here redundancy and complete region going down is like very rare scenario, right? And they want us to keep the cost minimum as possible. So you opt for zone. If you go for geo, that's of course correct answer, but that won't fit in our criteria or fit in our customer's requirement. We need to understand our customer's requirement very closely to provide them the right solution. I mean, geo will also work, guys, but I mean, let's say I'm a data engineer with less experience, and I say, let's go for geo. This is like very high availability. But at the end of the month, when they see the bill, the price, it would have crossed out of budget. So they want to keep their cost minimum. Then we suggest zone. So that's the reason we go for zone. And I think last day we have another session on this practice quiz. I'll try to add as much as I can after each and every session so that you get some better understanding about these. But last day we have whole session on 65 bits, and I hope half of the questions will repeat from them. Let's hope for that. But we will try to go one by one of those 65 questions. But last day we have that session anyway. Thanks for your participation. I'll close this one now, and let's get back to our session for today. Thank you, guys. Really well done. Most of you got almost all the questions right. But the ones who've got wrong, don't worry. At least you've got the concept. You will never forget them because now you know the right answer. Discard. Okay, so what are we trying to do today is NoSQL, right? Not only SQL, which is CosmosDB. That's what we have in Azure. And this is really important, guys, because this is the other, because if you remember on day one, we have 3 different kinds of data when it comes to data classification. We have structured, and we know where we store structured data. It's SQL databases. And we have unstructured, and we have big data systems for that. And all the different kinds of photos, videos, and all those files, we store them. But for semi-structured data, lately they have identified that, okay, all these big data systems and all, they kind of, getting all this semi-structured data, especially the web data, right? XML and JSON, these kind of structures. So they wanted to store this data, and also they don't want it to follow the schema, because when it comes to SQL database or structured database, we know the schema. So before defining or designing a table, right, you need to know what columns you are getting there. You discuss with your customer, okay, give me the list of columns, give me the data types, give me what kind of data you're going to get, frequency, all these kind of informations you discuss with your customer, being as a data warehouse engineer or a data engineer while you're designing a data warehouse system, right? Then based on that, you will design your systems with all the primary keys, composite keys, all these kind of things. You need a schema there. You need a structure. But when it comes to NoSQL, right? Because, we've already seen a question on that. You can have different attributes coming from different people. And you cannot really anticipate, like, all the users might be providing all the data within the format or within the schema what I have defined. No, that might not be the case or scenario there. So in that case, we opt for NoSQL databases. And let's start with the slides, what the slides are saying here. Okay, so in RDBMS, right, relational database management systems, what were the issues we had? Of course, in the cloud, I think these issues got sorted. Scalability, now you can scale, because if you've closely monitored or observed what Laksh mentioned in SQL database session, whenever you launch a database based on the DTUs, right, database transaction units. So that's like a metric. I mean, that's something like throughput. That's a combination of memory, IO, CPU. So based on that, you launch your SQL database either based on DTUs, right, or based on vCores. So you have DTU model, you have vCore model. So in that scenario, you can scale the database, right? At least now we have an option. But back in days, we had an issue on scalability. If you have an on-premise database, to scale that, the only option you had is vertical scaling. Either you improve the storage, let's say you have like 10 gigabytes, now you want it to improve to 20. So you can just vertically scale it. But horizontally, if you wanted to scale like a distributed system, like Hadoop distributed system or a big data distributed system, that wasn't like a possible scenario for on-premise systems, right? And flexibility. So even with this option, we had some issues back in days. So then what is NoSQL? Like I said, NoSQL is not only SQL or no structured query language, and horizontal scaling is possible when it comes to NoSQL. So this is the issue which we try to overcome from the SQL databases. So here you can horizontally scale. When I say horizontally, I think we have another slide which is coming up, the difference between vertical and horizontal, but that is possible in NoSQL. And here it is quite flexible. Like I said, right? You don't really have to have a schema or discuss with your end users beforehand what the table structure is going to be. No, you don't really have to worry about that. You design beforehand, then you figure out, okay, what is coming, what is not coming. So here you don't also have to worry about the schema. So no schema is enforced. So that's actually the flexibility we have within NoSQL. Okay, like I said, you have two options when it comes to scaling, right? You have vertical scaling, you have horizontal scaling. So usually whenever you want to store more data, what you do is you add those units, like I said, DTUs, vcodes. When it comes to NoSQL, you have request units, RUs. We're going to discuss them. That is the throughput. So you have storage, throughput. So RUs will be completely classified into two, throughput and storage. We will get there. But here, based on the request units, right? Based on the RUs, you can horizontally scale them. Let's say you wanted like one more node. You just request one more node. You want like 10 nodes because you have anticipated that you have a machine learning model, let's say, and that model takes like so much of data and it has to like, train on lots and lots of test data, right? You need both computing power. You also need the storage space as well. So in that case, you wanted to have like more number of nodes for limited period of time because you're just doing a training. You're just experimenting with your model. So once you get the accuracy, okay, I'm not really sure why I have shifted from data engineering to data science. But anyway, so what I'm trying to say here is based on your workloads, you can scale your nodes, and that's possible here. And everything will be like internally integrated. The data will be distributed, right? We will see that. So vertical scaling is nothing but adding more RAM, HDD, CPU in the same system. Horizontal is adding more commodity machines. Okay, so this is like a typical table, right? So you have like orders and order details. So this is usually what you see in SQL database, but when it comes to NoSQL, this is what you're gonna see. This is like a document structure. We call it as like a JSON documents, but usually this is like key value pairs, right? So you have order, right? And all these attributes. And again, within order details, you have like sub attributes, right? Like, inner loops, like, you have like a root node and again, leaf node inside this. So usually what you do for this, when it comes to SQL database, you create another table with order details and you put all this information in that table. But here, if you see, everything is in one document, right? When this is really great. Because when it comes to SQL database, you have to create order and you have to create order details in another table. But here you can just maintain that. Even if you have like more attributes which are coming, unit price, order detail, right? Quantity, product ID, order. I think here the schema is same for these. Let's say you have another column here or two different other attributes here. You can add them and they might be missing here. That's still fine because this is schema-less. It doesn't have a schema. So yeah, this is what we've discussed actually. So within customer, you have name, again, email, status, again, products. Usually in products, we put like in a different table. This is like a big table, big query. If you have heard those terms, right? Google has their own big query and big table where they store all the table in one place. Because the main advantage with this is when your data lies in different tables, right? Again, there are pros and cons for both the systems. When your data lies in different systems, if you wanted to do some analysis on top of that, like, OLAP systems, right? Analysis or data warehousing systems, you have to join. You have to use all those left joins, right joins, inner joins. So usually while you're doing joins, those are like costly IO operations because the data is in different system. It has to come to another in-memory cache and then it will display the result for you. So there is some IO computing operation which is happening in the backend. And again, performance, right? And the latency. So many issues. Just imagine all the data lies in one table. So there is no point of like, using joins. So everything lies in one table. Maybe we add some indexing and boom. When you query based on the index, you get the result. There is like no join operation, no IO operation. Very straightforward. So in this case, for products, you don't have to create another table. It lies in the same document. So you can call it as a document. You can say it as a semi-structured data. You can call it as BASIN. No, I think BASIN is different. I'm going to show you that. You can call it as JSON, right? It has got like different names. Just try to understand the structure, like key value. NoSQL use cases. So mainly NoSQL use cases, you have them in big data and real-time web applications. So for IoT and stock market, and also for big data storage. Like I said, the main reason we have added big data is because you can do a horizontal scaling here. When it comes to big data, you wanted to have that commodity scaling. Vertical scaling, of course, there is the certain threshold. 100 GB, okay, 1000 GB, done. After that, you can't, because that machine has the limitation. But when it comes to horizontal scaling, you can add as many as nodes you like based on your storage requirement. And here, when the relationship of the data is not really important, right? So like I told you, you don't really have a schema, so there is no relationship. And whenever you have a scenario where the relationship is not really important, then you can use this. And data change frequently. So if you have like frequent data changing situations, you can use NoSQL. I think on this part, I can do a little bit debate, because usually for transactional databases, if you ask me, I will prefer SQL databases. But for semi-structured data, transactional database, I would say you have to go for NoSQL. But usually, comparatively, SQL databases are faster than NoSQL. But data change frequently, yeah, because you never know which kind of data you're going to get there. But that's the reason you have this. Okay, so like pros, we also have cons. Like we have certain limitations. So schema-less means inconsistent, right? For some attributes, you might get like that column data, and for few, you might not get. So that space is like completely emptied. And that's like, inconsistent data, right? When I talked about the big 4 V's, volume, velocity, and variety, there was one more thing, the accuracy. I forgot what we call that. But yeah, so the accuracy, oh, someone is trying to help me here with the chat. Oh, veracity. Perfect. Thanks, Oak. Yes, the veracity part, right? So there, we have to be very careful when it comes to the accuracy, right? We maintain MDM systems like master data management, because we don't want that inconsistent data to be in one place, because it might cause some issues when it comes to analysis. And again, denormalized data means redundant data, right? So you know what is normalization, denormalization, because usually this is a concept we have on SQL Server. So usually when we have this star schema, right? Whenever you design this data warehousing system, the fact table is surrounded with all the dimensions. I think this concept, we will go deep when it comes to Synapse, because Synapse is a cloud data warehousing system. Guys, remember Synapse, 50%, very important. So in that situation, right, you have a fact table and all the dimensions are surrounded by this. Let's say you wanted to do let's say you have a table called date time, and you have all the year, month, date, everything. And you wanted to, again, like, normalize that, right? You wanted to, again, like, make another granular level of all the year data should be in one, month data should be in one, all the week data should be in one. So you can, again, like, create different tables so that you have consistent and you have proper schema. And the other one is redundant data means inaccuracies. Again, conflicts we have discussed, inconsistency and inaccuracy, and does not support many good features of relational DB, which is store procedures, functions, views, row level security. This is very important, row level security, right? But guys, just remember this: store procedures, functions, Azure Cosmos DB, it supports them. But there are few on-premise NoSQL databases which doesn't support this. But I think they are putting a lot of effort and investment on that areas, so that now the few of the NoSQL databases, they support store procedures and functions. But row level security, no, this is not possible. But logs, it is possible. I think I've shown you a tab where you have logs. You can create logs, but these logs are different than what we've discussed. The logs which I mentioned you, if you add a log, no one else can come there and change the service or make any changes to that particular service. For example, Azure Storage Blob, you have added a log. No one else can come and delete that storage account. That is different. But here they are talking about, like, row level logs, but that's kind of not possible. Okay. And maybe some other things. So in a very high level, these are certain limitations, but I think few of them have got rectified and they're still working on this, because, like I said, like big data, that's the boom. And people wanted to, like, put more and more investment on this and do more developments. So very high level difference. This is relational, this is non-relational, fixed schema, dynamic, designed for complex, not for complex. And the examples are SQL, MySQL, Oracle, Postgres. You have Mongo, Redis, Hbase. Guys, Hbase is again an open source NoSQL database. For me, when I started working with big data systems, I think Hbase was the first thing which I've used, right? So in Hadoop's distributed file system, you have all the files which are underlying in the file system, right? And it's like file system. You cannot really query them. On top of that file system, someone from the open source community, they have built on this NoSQL database. They've like a lot of investment and built this Hbase, and they've again released it as an open source technology. So I think most of the NoSQL databases you see on cloud, they have adapted from Hbase. So Hbase is nothing but a layer on top of HDFS layer, because HDFS is a file system layer which lies on all the nodes, right? On top of that, there is another software, another application called Hbase, which you can install. And this Hbase will read all the data from those CSV files which are on those file systems. And when you try to query using those, we have certain queries for Hbase as well. So based on that key value queries, you're gonna get the data. And this is mainly added because they saw a lot of performance issues and all. And that's the reason they wanted to create a portal for the end user where he can query something, especially for semi-structured data. So that's how this Hbase has got created. But again, similar to MongoDB, again, licensed NoSQL database, which is very high in demand right now in the market. People are doing so many certifications on this, right? SQL, vertical scaling, horizontal scaling, row oriented, here multi-modal oriented, guys. So what is multi-modal oriented? I think I have a slide on this. We'll discuss. So here you call table, here you call collections, containers. So you've got different names. So this is for limited, this is for great big data. Okay, so mainly when it comes to NoSQL database, right? So we have mainly 4 different types, right? Even out in the market and again within the Azure as well. So the first one is a document type, which I've shown you, right? JSON, where you have like, a relationship like parent node, leaf node. Again, within leaf node, you have like internal leaf node, right? So this is like a document. And then you have another one, which is called graph. So mainly this is used with all the nodes, edges, vertices, right? So we're going to discuss what is graph. In a very high level, we don't really need this because mainly we'll be focusing on this document. This is very important because by default, if anyone wants to start with NoSQL, they'll start with document. But graph, key value, wide column, these are for specific use cases, right? For example, an use case for graph is Facebook, right? So let's say this is Vinod and this is like maybe Omkar and this is Vishwamitra. Let's say maybe this is Vinod and this is Vishwamitra, and Vinod is a node and Vishwamitra is another node, and the relationship is, let's say the H, we call it as friend, for example. So these kind of relationships, right, between each and every node and between each and every data point, right, that usually lies within this graph NoSQL database model. So for those kind of use cases, they use these kind of databases. And then you have key value. So Azure storage account, right? The one which I was talking on day 1 session, I believe. So there you have key value. But if you consider this entire set, right? This entire set of 4 types also work with key value. If you wanted to retrieve a value using key, you can retrieve the value, right? So this is mainly focused on key value system. And then you have this wide column. So I think Cassandra is an example for this. Cassandra NoSQL database. I think Cassandra was also started as an open source. I'm not really sure if they have licensed it now, but usually this is like a wide column based. The thing is, in SQL database, everything is like row oriented, right? So here it's column oriented. The data gets segregated based on the column. We're going to see that with very small example so that you get better understanding. But what you need to remember here is, at least, right, when it comes to NoSQL, you have 4 different types, right? That's the outcome, or that's a key takeaway from this slide, at least. Okay, I think we have elaborated more on this each and every. Okay, so key value, like I said, you have key, which is Bob, and you have value. So you have key, you have value, you have key, you have value. Very straightforward key value relationship, right? So this uses simple key value, quick to query, because the keys and values, they're like completely mapped and very straightforward, so that for you it is very easy to query. If you wanted to query, let's say, give me the data for Bob, then you add Bob and then you get a value. We're going to see that how we do that in Azure Cosmos in the lab and exercise session. And the value can be JSON, blob, string, it can be anything. So here Bob is a key, and here this value can be a value, it can be a string, it can also be a JSON document. So here it can also be a JSON document. Okay, so main use cases for website, blog comments, IP forwarding tables, shopping carts. Yeah, and this is very important, guys. When it comes to key value, so what do we have in Cosmos? So in Cosmos, you have different APIs, right? We talked about 4 different types of NoSQL databases. Yeah, document, graph, key value, wide column. So Azure Cosmos DB is not part of any one of this because it is a multi-modal, guys. Because it supports document, it supports graph, it supports key value, it supports wide column, and it supports them with using APIs. So if you wanted to use document, then you use Cosmos DB MongoDB API. If you want to use graph, then you have a Cosmos DB Gremlin API. If you want to use key value, then you have like, table API. For wide column, you have Cassandra API. So Cosmos DB is one multi-modal, like, mission critical, globally distributed database, which supports all of these 4 types. I think that was the reason why we had this multi-modal oriented, especially when it comes to Cosmos DB, right? There are also some on-premise databases which have multi-modal. I think I have an example for them. But when it comes to Azure and cloud, we have Cosmos DB, which supports all of these, right? That's the reason in the example, you see, for key value, we have Cosmos DB table API. I think for this, I have elaborated, we have different APIs. So example, we have Cosmos DB table API, Redis, table storage, right? Azure table storage, Oracle. I think even Oracle has its own NoSQL. Yeah. So you also have different, but we don't really have to go that deep. Document store, very straightforward. I won't explain it again and again, but again, key value, but this is like, root node, leaf node, and you have no schema, but mainly the NoSQL database started with this JSON. That's my understanding. I might be wrong as well, but this is document oriented. The reason why they call it as document is because it's a JSON file, and they say JSON document, JSON file, both are kind of similar, So oriented model to store data. Similar to key value, like I said, you have again key, you have value, you have key. Within the key, again, you have a key, and then you have a value. If you want to retrieve Bob, right, you write like customer dot name, then you get Bob. If you want to retrieve email, then you write customer dot email, then you get email. It's like, there is some pattern there. Each record is associated with a single node, and the document stores are usually XML, JSON, BASIN. I think what is BASIN? I have one slide. It's nothing but a binary JSON. You know what is JSON? It's like JavaScript object notation, and BASIN is binary JSON. So JSON, we understand, it's like human readable format. BASIN, system understands. And this is mainly used for like more performance because, it's kind of close to computer language. Binary language. We don't understand, but system understands. So that there is very less time in the interpretation and all the conversion in the language in the backend. So you get like fast results. You have AML script and etc. So use cases, again, for block comments, chat sessions, you use tweets, ratings, content management systems, kind of similar. I think you have kind of your overlapping based on the use case. So examples, this is important. Cosmos DB, right? In Cosmos DB, you have an API for this. I think MongoDB API. You have MongoDB, right? Document DB, CouchDB, so Orient DB. These are a few of the examples for this. Then we have column store, wide column, wide store. I think everything is kind of similar. Like I said, Cassandra is an example for this. But when it comes to Cosmos DB, we have Cosmos DB Cassandra API. So usually what it does is it's mainly a column oriented model. Okay. So like we said in the previous example, we've seen that like for Bob. So you have email, gender, and age, right? So this entire data gets stored in one column. This entire thing is one column. Again, within this, it's key value. See, at the end of the day, whenever someone says semi-structured, for me, it's key value. Again, for Brittany, you have another column. For Tori, you have another column. So there is a very slight difference between document DB, column store DB, right? And also like key value DB. Very slight difference, but that difference makes a huge impact when it comes to performance. Mainly, this is used for sensor logs, IoT, and reporting systems, time series data, right? And yeah, these are the examples for this. Because, it's extremely quick to load and query. There are two different things. One is load, the other one is query. Load is nothing but, you are dumping the huge data from picking one system and loading. Query is nothing but you wanted to query and you wanted to select the data and see. right? So query is mainly used for analysis purpose and load is used for data integration purpose. So few systems might be really fast in loading. Few systems will be really slow in querying. So we're going to discuss in a very depth, because these two terms, they might be like very high level, but there is like what, like I can talk like 2 or 3 days on these two topics when it comes to Azure Synapse, because you might see so many questions, especially on Azure Data Lake, sorry, on Azure Data Engineering Certification with these terminologies. And graph store, like I said, right? So you have relationship. So I think this is an example which I picked from some other slide. But usually if you see, you have friends, like I said, an example from Facebook, right? So here you call vertices, like maybe nodes, and this is the edge. Edge is kind of relationship between these two. So it can have like different relationships. Mainly it relates like how the data is related, right? So a node is a specific entity or piece of information. So this any is an entity. SAM is an entity. So it's like entity to entity relation. Okay. So it's a mainly relationship between two nodes, social networkings, like I said, and real-time product recommendations, right? And also network diagrams. So I think there are some nice fancy tools if you're from networking background. So usually they kind of provide these kind of visual scenarios where you can see how my system is working and what is the relationship between those two, like node 1, node 2, node 3, node 4, and what is the relationship, kind of, right? And examples, like I said, CosmosDB Gremlin API. Within CosmosDB, we have an API to use for this graph, Neo4j, right? And the Blaze graph. And again, OrientDB is also supported for this graph store. Okay, so multi-modal. So multi-modal is nothing but it includes the features and characteristics of more than one data model. So far, we have discussed like 4 or 5, right? So let's assume that each one is one data model. Let's try to combine all of them. Then we call it as a multi-modal. When it comes to SQL, you have only one model, which is like schema, database, rows and columns, table, structure, period. But here you have different relationships for Gremlin, for graph, for key value, for document, right? So if you try to combine everything and put it in one place, or if there is a system which supports all the models, then you call multi-modal system. We already have multi-modal systems. I mean, this is nothing new that Azure has come up with. So we have OrientDB, again, ArangoDB. I think this is an open source. They're also providing some professional certifications on this. Maybe if you're interested, you can. So this supports key value, document, and graph, right? But usually big organizations, they don't really trust these open source systems because they kind of scared that if the system is in production, if something goes wrong, whom to contact, right? But we already have multi-modal supportive systems in the market available. Okay, NoSQL offerings by Microsoft Azure. So I think we've already seen this chart, right? In Azure, we have infrastructure as service and a platform as a service. So this is nothing but you set up your VM and then you install your database. Let's say you already have a MongoDB license. You've already bought it and you already have some kind of relationship with the MongoDB relationship manager, and you wanted to continue that, but you wanted to still leverage cloud as well. Then you just set up the VM and install all the required prerequisites which you need to install MongoDB database, and just lift and shift and directly install that. So this is where you utilize infrastructure as a service. But Azure says that you don't really have to use like, this one, use platform as a service and use CosmosDB and use CosmosDB MongoDB API, so that my CosmosDB CosmosDB, and within that CosmosDB, I already have a MongoDB API, which is directly, or which is kind of similar to MongoDB, which you are using, and it integrates with the MongoDB, so that using that API, you can completely replicate your on-premise system to the cloud. You don't have to go and again set up a VM and you have to use, no, I already have that. You can utilize mine. So that comes under platform as a service. So again, within platform as a service, you have 3 different types. Azure Storage, we've discussed. Data Lake, we've discussed. And we know what is the relationship between these two guys. And Cosmos DB, we are going to discuss now. And within Azure Storage, okay, I've got 30 more minutes. Okay, I'll quick it up. Within within Azure Storage, we have again 4 types. We've discussed: blob, table, file, and queue. Forget about these 2 now. We've discussed blob, very detailed discussion we have done. So we already have a table, right? We already have Azure Storage table, which kind of supports key value and semi-structured data. Then why do they have come up with Cosmos DB? If you ask me, whoever is already using Azure table storage, right? If they wanted to go for the premium option, It's like a prime version. If they wanted to upgrade themselves, then they have to use CosmosDB table API. And then they can upgrade from Azure storage table to CosmosDB using that API. So already for the existing customers who are already using Azure table storage, if they wanted to upgrade themselves to the premium version, they can utilize CosmosDB. And you have so many advanced features when you compare with the Azure table storage, but you have all those advanced features in CosmosDB. We're going to see them, right? So that's a main difference between these two. But here in the table storage, you can only store the data in the form of key and value, right? If you wanted to store like JSON or like, graph related thing, that's not possible here. So within this Azure storage table, you have a lot of limitations as well. Okay. If you've again, I just wanted to add this point here as well, because if you've closely noticed what I've done in the redundancy part, right? I think it was in the redundancy. Yes. So you have like different types of redundancies, right? So there you might have seen with the small star saying that maybe these redundant options are only support to blob and file, but not to table. Like I said, there are certain limitations. Maybe I'll just create a slide on that, what limitations we have with respect to Azure storage when it comes to table API. Maybe I'll add that slide and I'll show you. But the thing what I wanted to say here is all the features you have for blob and file, they doesn't support for table. That's the main takeaway from this slide at least. Okay, so advantages of blob storage. Why do we have this here? Okay, it's cheap, we know. We have seen this blob, cheap, simple to set up, no configuration, doesn't require powerful computing to manage. Yes, maybe someone might say that, you can also store JSON documents in blob, right? Why do we need NoSQL databases? Good question, guys. But there are certain limitations in blob storage. You can't do indexing. And there are no searching tools, right? Because all the data is stored in the file systems. And if you want to search, it's a hectic thing. And it's not optimized for performance, right? And again, replication and synchronization, like I said, so you have to set up that replication, and you don't have like multi-writes. We will see what are multi-writes when it comes to Cosmos DB. So requires external compute to process. Like I said, blob is mainly or is only used for storage. But if you wanted to query, right, if you wanted to do some sort of analysis, you need to depend on external compute process. Again, these are few of the limitations we have in blob, because someone might really argue saying that I can use all those JSON documents and dump them in blob storage or maybe in the data lake. Why do I need to go for Cosmos? So we are trying to eliminate these limitations using Cosmos DB. Like I said, in a single word, what is Cosmos DB? Globally distributed. We will discuss why they say globally distributed, because like I said, it's a horizontal scale, right? And that horizontal scale will be globally distributed in different regions. Multi-modal database service. We know what is multi-modal, I think by now. For mission critical applications. When I say mission critical applications, these systems, especially Cosmos DB, that's mainly used for transaction systems when it comes to IoT data, gaming data, stock data, mainly for semi-structured data, right? That's the reason they say that this is also used and mainly used for mission critical applications as well, so that you don't have any downtime. You have very high availability. Most of the services within Azure has that high availability feature, but this takes precedence because this has got more priority. Why and how, we will see that. Okay, why Cosmos DB? Okay, fully managed, right? So it's as a database as a service, serverless architecture. You might have heard this word. I think back in days, at least a year or 2 years ago, serverless was like a word which I used to hear everywhere. There's like serverless, serverless, serverless. Serverless is nothing but that, you don't really have to worry about the server. If you wanted to scale, you just send a request, or you can just do it by yourself from the portal. So there is no server, you cannot see the server. But in reality, right, there is some server somewhere. But for us, it doesn't really matter because the ownership of that server is Azure, and it's their responsibility for us to give high availability. No operational overhead, like, infrastructure setup and all, you don't really have to worry about that. And no schema and index, and you have index management, guys. Like I said, like, you don't have schema, but you have index. Why we need index? I don't really want to explain what is index and all. That's again a deep concept when it comes to SQL Server or relational databases, but mainly index is nothing but you get like a numbering system so that it gives a very good performance when you're trying to do some query. Globally distributed, right? We will discuss how you can globally distribute this. Multi-modal and multi-language, and it supports all these kind of different languages. So you can connect your system with Java, .NET, Python, Node.js, JavaScript, and you can use any of these programming languages and try to query the data which is located or which is stored in CosmosDB. Highly available, like I said, it's 5 nines SLA and less than 10 milliseconds latency. Scalable, you have both horizontal and vertical, but usually we don't say vertical scaling because we have an option of horizontal scaling. And mainly the scaling is based on request units, which is like storage and throughput, the combination. We're going to see that. Consistency choices. So here, when it comes to Cosmos DB, you have like total 5 consistency levels: strong, eventual, consistent, perfect, prefix, session, bounded states. So if you wanted to attempt and be very confident when it comes to NoSQL or Cosmos DB and answer all the questions, or whatever the questions you're going to get in the exam, you need to be very confident on this concept, consistency choices, right? This globally distributed. I think these two concepts are very, very important when it comes to exam. We're going to go deep into them, but you might get tricky questions from this guy and tricky questions from this guy, and we're going to see how they are. So they're like very quick few use cases. So it can be used for IoT, right? So you get data from my Azure IoT Hub. We're going to see IoT. I think we have these concepts. Azure Stream Analytics, that's part of our program. We're going to see that. Azure Databricks, we have this. I'm not really sure if you're following with, I'm not really sure if you've connected with my LinkedIn profile. I think I've shared something there because Azure, especially on the Databricks side, so they have some self-paced trainings. I just wanted to highlight that here because if you're interested, you can also enroll for that. I'm not really sure if the offer is still valid or not. So if you can go to my profile and look at my post, I've added that yesterday. So you can go to their website and under learning paths, you can select either data engineer role or data scientist role, and you can enroll for free, and you can get like a certifications as well. Usually that is worth of $2,000. But right now, due to some issues, they are giving it for free because they wanted to spread their technology across the globe. Because the only way they feel that to spread their technology is to give it for free. But again, this is not Azure. This is just the Databricks. I think Databricks on premise. So that is where you learn about Spark, streaming, Spark ML, right? All these concepts you have. So you have like professional certifications. So they are giving right now for free. So you can just go there, create an account, enroll and register, which is for free. I think either for engineering course or data science course, you can choose whatever you like. So anyway, we have Azure Databricks. We have a course on that. We have 1-day session. So here, what I wanted to highlight is, let me not deviate on the concept. For IoT use case, you can use Azure Cosmos DB, right? What is TTL? We're going to discuss. Time to live. You can define that. And there is another use case, retail and marketing. That is where you can use your Cosmos DB, where the data is coming from Azure Web App, right? And then the other use case, gaming. So you have this Azure Traffic Manager, which is again like a load balancer, Azure CDN, and you can utilize some APIs and send the data to Azure Cosmos DB. And from there, you can retrieve it using Azure Databricks, or you can utilize Azure functions. So we are here trying to learn about each and every component, right? But when you try to work as a data engineer, you need to know the entire unified architecture. So you won't get an opportunity. Let's say I'm very good in NoSQL. Give me an opportunity to just work on NoSQL. No, you should also be good in Azure Databricks. You should be good in using Azure Databricks notebooks, writing some expressions, scripts, and everything. Because to do all that, just remember that when it comes to data storage and transformation, right? We are just talking about storage part. We have got transformation coming, right? That is really important. And again, web and mobile use case. So here also you can use this. So I think what here we are trying to say that the Cosmos DB has got use case in different domains. So there are no limitations. You can utilize this in all the domains. Okay, when it comes to NoSQL, like I said, you have 4 different things: key value, column family, graph, document, right? So different APIs you have: table API, Cassandra API, Gremlin API. You have MongoDB API, and you also have SQL API. You have like 2 different APIs, right? But for SQL API, guys, The other important feature and the interesting and the advantageous feature here is you don't really have to worry about any new semi-structured querying language. No, like I said, right, SQL and Python. If you have these two instruments, if you have like these two weapons in your pocket, you'll be like a very good data engineer in the market. Trust me. To have or to gain tremendous knowledge or to be very confident if you're being as a data engineer, going there and setting up all the production system and defining and designing all the pipelines, you need to have SQL and Python languages in your pocket. So like I said, when you store some data, right, in JSON format, if you wanted to query it, you can use SQL language. So you have Data Explorer, like we have Storage Explorer for storage account. For Cosmos DB, we have Data Explorer. It also gives us a tool, like an interface, where you can write all your SQL queries and it will retrieve the data which is in semi-structured. And this was not possible back in days. But now we have that option. If you know only SQL language, use that SQL queries to retrieve the data, whatever you need. This is amazing feature, guys. Like I said, again, the main difference between SQL, because usually for document storage, you have these two, but there is very slight difference between these two. So SQL mainly deals with JSON, but MongoDB deals with JSON, like I said, like binary, right? I think I have an example. What is JSON? JSON file kind of looks like this. We've already seen this so many times, but I'm interested in showing how JSON file looks. So JSON simply stands for binary JSON, right? So let's say you have written your JSON file in this, right? Hello key world value. It kind of internally converts into this binary format. So which allows it to be parsed much more quickly because system understands this language. System takes very less time to process this. So this is a major difference between these two. And again, you can use SQL like query language, right, to use this. And also here you can leverage SQL query API for new developments. And again, use the MongoDB underlying storage to query using SQL. So what I'm trying to say is, let's say you already have a MongoDB setup, right? And now you want it to, because in your organization, you have your team and everyone are very much familiar with SQL and you don't want to really hire some other guy who really has an experience with MongoDB, for instance. In that case, what you can do is you can leverage SQL Core API to convert this data or to shift the data and then leverage your SQL queries. I mean, it's again up to us how you want it to design, right? What is convenient and what is not. Let's say you have a system architect who is familiar with AWS. And now the customer comes to him and he says that, can you please design a cloud structure or cloud architect for me? He will definitely suggest AWS because he has knowledge in that, right? He won't go to Azure or he won't go to Google Cloud Computing saying that, let me explore all the other multi-cloud systems so that I can come up with a better solution or less pricing. No, based on his skill set, he will provide solution. So here you can change that thing, right? So migrate existing Cosmos DB without much change of logic. So when it comes to MongoDB API, you can use this API for on-premise MongoDB database and use this to migrate to the Azure Cosmos DB using MongoDB API. Cosmos DB table API. I think, like I said, we have 4 APIs. Again, these are going in depth, right? Again, we have Cassandra for wide column. You use this. We have Data Explorer. I'm going to show that how it looks. And for a graph, you have Gremlin API, mainly used for graph data model, right? Okay, I think we have another example, but mainly this is like the relationship. You have mobile, you have location, the relationship is location. You have mobile and you have operating system and the relation is OS. So kinda, it's like edge versus node. You don't really have to go deep into this, but we can definitely, if we have like use case where we wanted to leverage graph, right? Let's say like you've got like enough knowledge and training on the graph, and you now go to your organization, say that let's try to implement graph because I've got this IoT data. Let's try to do all this entity to entity relationship where you have like more performance. You can do that. Cosmos DB Gremlin API. So mainly the use cases, if you wanted to use this, social networks, recommendation engines, this is where you use like, e-commerce recommendation engines, and geographical data, geospatial, so that you have latitude, longitude relationship there. Internet of Things, mainly for industrial IoT or like normal IoT. Right now we have all this self-paced, self-driving cars where they generate like big data, like, because every second so much of sensor data is getting generated. And in those situations, you use this kind of thing. Okay, so when to use what? Because we have got a big list here. When to use what? So here you have a simplified table, right? So let's start with this. Existing MongoDB, Cassandra, Azure Table, Gremlin. If you have this in your on-premise systems, then use the respective APIs to migrate them to cloud. Okay. And for all other scenarios, use SQL Query. And for all the new projects, use SQL Query. SQL Core. Because Azure recommends to use SQL Core because, like I said, most of us have enough knowledge in using SQL query, structured query language. We have enough experience there. So that's the reason like Microsoft recommends us to use this so that, you can also query the data irrespective of the underlying data like JSON or anything, you can query that using SQL queries. Okay, so I think this is like very high level difference between these two, right? Initially we were talking what is the difference between table storage and CosmosDB table API. Like I said, CosmosDB table API is a prime version of table storage. You have table storage. If you want to go for a premium version, then this API you leverage, right? Again, some very high level differences. Geo replication is restricted. Like I said, the geo replication is only possible for blob and file, but not for table. But like I said, I'll create a slide on that so that we can have clear understanding. But here geo replication is possible for all the regions. Supports only primary key lookups. This supports for secondary as well. And here performance is better, right? And here consistency options you don't have, but here, like I said, we have 5 consistency, guys. This is very important when it comes to questions, right? When it comes to certification, when you want to clear, you need to have very good understanding on consistency because they might ask you tricky questions. In a very high level, this is the difference between storage, table, and Cosmos. But at the end, both store semi-structured data. Very slight difference, but makes a lot of difference. Okay, so database and containers. I think by now I should have shown you how it looks in the system. Let me quickly go to my system. Okay, we've got like 10 more minutes. Let me show you how to do that. Okay, so this is our home tab, right? Let me take this guy. And now you go outside. So here you have Azure Cosmos DB because I've already used it. That's the reason I've got it here. Or else you can just type Azure Cosmos DB. Okay, just click on that. I've already created 2. So if you want to create a new, just click on this create. Like I said, I think now you should be able to see the content and everything much better than the previous 2 sessions because we haven't used that zoom option, but now it should be easy for you guys to follow. So here, like I said, you have different APIs. Okay, you have core SQL, Mongo API, Cassandra API, Azure Table API, Gremlin. Like I said, based on your requirement, right? You try to use that corresponding API. For now, let's try to, because we are doing a new development and Azure recommends to use core, right? For all the other scenarios, because I don't really want to leverage any of this. Let's try to create this one. So while creating, again, it's same. You need to provide the subscription and resource group. I already have a resource group I don't want to create. Click on this. I've created a new resource group for Databag NoSQL demo. And here you need to add an account name, right? So you need to give an account name. So NoSQL demo 3, because 1 and 2 I've already created. If I give 2, yeah, because it's not available because I've already used that name. So 3. So location. So let me select this West US 2 location. Again, location is very important, guys, when it comes to a NoSQL database because of latency, right? So if you want to have less wait time when the user queries or when the user sends some query so that it needs to retrieve some data, you need to be very careful on choosing this location. And we have multi-reads, multi-writes. We're going to see that, but you need to consider that. So here, capacity mode, right? So you have 2 different types here. One is provisioned throughput. The other one is serverless. Serverless, pretty straightforward. Okay, this option is gone. I'll tell you why this option is gone for me. Before going there, serverless, right? So serverless is nothing but, you don't really have to worry about this, right? All the request units and everything are completely provided to you based on your demand. So you don't really have to worry how many request units I need to add. Again, before thinking too much about request units, I'll explain what are request units, but you need to understand that the capacity, you don't have to worry about that when you opt for serverless. But when you opt for provisioned throughput, right? Provisioned throughput is something that you assign request units, right? You provide, let's say I want 400 request units, 1000 request units, or 2000 request units. So based on the request units, you're going to see the performance. So again, within the provision throughput, you have two different types within this. Again, manual and auto scale. I think when we are trying to create the container, we will see the difference between manual and auto scale. For now, just let's try to create this on provision scale, provision throughput. So here, when you're trying to create this for the first time, right? So usually, like all the Amazon and all those eBay and online stores, Amazon also provides some offers when you're trying to create, because they wanted to promote this CosmosDB more and more, because they've already put a lot of investment on this. So you'll get like first 1000 request units and 25 GB storage free whenever you create for the first time, right? I've already created my first account and this is like my third account, so I don't really get that. But usually when you get that, you get this option and you can apply for which account you want to create, right? And that's it. Then go next. Let's ignore this geo redundancy, multi-region rights, availability zones for now. And again, connectivity. So you can also add your public endpoint or private endpoint. So that specific virtual network, from that virtual network, you want your applications to connect, you can enable them here. Either you can do it now while creating, or once you've created, you can also modify them as well. Then you have backup policy. We will see this. And then you have encryption. Then this encryption is again similar, right? One is service managed, which is Microsoft. The other one is customer managed. Once you select customer managed, it will ask you to add your key vault link, because usually you store all your keys in the key vault. We've seen this, right? In storage data lake, we've seen that. Again, you have that option here as well. Then you have tags, and then you have review and create. See, once you add all those options, based on that, it will also give you an estimated time, like how long it's going to take to set up this entire database, provision this entire database. Okay. So if I click on create, it's going to take some time. So I've already created one. So let's go there. CosmosDB. The 3.1 is now creating, right? So let me go to this one. If you want, I can just zoom a little bit more. So usually once you create the CosmosDB, right? So this is the home page and this is how it's gonna look. Here you have the status online and which resource group, which subscription it belongs to, and subscription ID, which is unique. And also, like, don't get confused. I have added these different read locations, because if you remember, while creating, we have added only one location, which is West US 2. And how come you have these different? Because this is a different storage account, guys. I've added these locations just to show you, because it's gonna take some time. So I've already added and I've already provided everything. We will see if we can see this today, or else we'll see it tomorrow. And you also have write locations. So our data will be written in these different locations. We will see that. And you have URI endpoint. And capacity mode, we have selected provision throughput, right? I think most of the things are very self-explanatory. We have already seen them. What I wanted to show you is, I was talking about Data Explorer, right? It's similar to the Data Storage Explorer, which we have seen for Azure Storage. If you click on this Data Explorer, yeah, you're going to get something like this. So this is where you're going to start creating your containers. Don't get confused. What is container? What is collection? What is item? If you know what is table, what is database, what is column, if you're going to kind of relate with that, I'm going to pull up a slide so that you will understand better on that. But here, usually you create containers. Either you create containers or you create database. We will see what is database, what is container, but just get used to this portal now. Just get used to this. So you have an option to create either a container or database. There is another option where you can link this with Azure Synapse. We're going to see this in Synapse class. And you also have an option where you can use notebooks. It can be a Jupyter notebook, and there are different notebooks. For me, I'm familiar with Jupyter notebook. And you can write all your Python code in that. If you're a data scientist to do some analysis, right? You're a data scientist or you're a data engineer, let's say, and all your underlying data is stored in CosmosDB. Now you wanted to do some analysis, right? So you can use your notebooks. And when it comes to gallery, right? So here, let me close this. You have two different things in SQL API. You have data. Within data, I've already created product. And within product, I've already created clothing. but we'll try to create new, don't worry. And when it comes to notebooks, we don't have anything. You have untitled one. If you click on this, you get like an empty. And here you also have a gallery. So gallery is nothing but, come on. Gallery is nothing but like, people like you and me, they already write some codes either in Python, .NET, right? So they already write some notebooks, they save them and they publish them. And then based on the selection, Microsoft will publish those things here on the gallery. You can have like official samples because you are completely new and you wanted some samples so that you can start. You need a starting point, right? So you can just open any of this. For instance, let me open this. So if I open this, I get all entire code, right? I think this is in Python. So you have imported some code and then you run each and every cell so that you see the data in interactive mode. And this data lies in the underlying CosmosDB. Of course, right now we don't have this data, but this is like a starting point for you. So you can also use those galleries. If you like, if you see that one of the galleries close to your requirement, you can take that. That will be your starting point, and from there you try to enhance it and try to add your requirements on top of that code, for instance. Because these galleries, the code in the gallery is open to use, right? It's not licensed. You can utilize that code as well, no worries. And you can connect to your GitHub, you can open terminal. So usually what I do is I go here. So here what happens is, because this kind of limits me to use this. So you can do like, you can open this entire data explorer in a new tab so that you can just focus and work on that. Either you wanted to open that with read and write option, you can open only with the read only option. We also wanted to read and write, right? Just click on this open, and then this data explorer gets opened in a new tab or a new window, right? So if you see all the options which you have seen there, you can also see them here. New container, right? Okay, because the region which I've selected, the region, for that region, the notebooks are not available. We will try to check in different regions, right? I think in this region, if you see, this is another one. So if you see here, okay, even here, the notebooks are not available. Okay, I'll check this part, no worries. But what I'm trying to say here is you get a new window where you can just try to. Okay, so you have this thing where you can use your SQL queries. Just for instance, I'll explain what and all these are. But for instance, let me try to, let's say this is a JSON document, okay, with ID, product, and let's say this shipping information, right? So now you wanted to add this information to this particular database. Products is a database and clothing is a container and items is a table, for instance. And you wanted to add this information to that. Just put your code here and then just save. I'll show you how I've created everything, but now I think we've got like 2 more minutes. So I just wanted to give you a quick glance how it looks. I think we have the data now. Let me add another data to this one. Okay, so if I wanted to query, right? Save filter changes. So usually for me, the product ID should appear here because there'll be like some latency and waiting time issues. But don't worry, we'll explore more on this in tomorrow's session. Anyway, today's time is like up. Okay, so you come back to this one and let me zoom out a bit. This guy here. The other thing which I wanted to show you, yeah, here if you see, initially we have added our data to West US, and guys, this is like globally. You can see where and all we have the data centers of Azure data centers, right? You can see them here. They have like located and pointed to different regions. So initially I have added my location to West US. And if I wanted to replicate to West Europe or Southeast Asia or Brazil, I've already added them, of course. Now you can see that reads enabled. So what you need to just do is like, you've already added this. Now, if I wanted to add another region, click on this, click on this. Now you've got like 2 more, Norway East and Japan East, and save. Of course, this takes time, right? So what happens is whenever someone is writing some data, right, uploading some data to this, it will be replicated to different regions. And users which are close to that region can connect to that system. I mean, they don't really have to change any endpoint or URL. System automatically recognizes the closest data center to the end user, and it will provide the data and the response for the query which end user requests, right? So with this, the user will not have any latency issues, and you don't really have to wait like, for any big data analysis if he's querying, right? Because the data is close to his data center. But we're going to see that in very detailed way. And you also have multi-region writes, and this is multi-reads, what I've explained right now, right? Again, for monitoring part, like I said, guys, if you've closely monitored or closely noticed what I've said for Azure storage, they are same for this. So I don't really think that I'll be repeating again the monitoring part, but if there are any questions, let's say if they want you to create an alert, right? And you know how to do that. You go to alerts and then create action groups and emails and everything. So based on that, you can create alerts, and you have insights, metrics, logs. We're going to discuss, of course, logs, because we missed that concept. Logs and log analytics. We will discuss that at least in this session, but you know what is metrics, alerts, insights, and diagnostic state settings, right? Again, this part is kind of repeated here. And what the other thing I wanted to show you is access control, right? So if anyone wants to give role-based access control, if I click on this, I am service administrator, of course. And if I click and see whoever has, okay, all my entire team has access to this, because I've already added them contributor for my subscription. Whatever service I create by default, they will have access to that. So based on, like, I think we've already cleared that question, and you might also get some questions on access control when it comes to CosmosDB. So you should be confident enough to give or provide that option, right? Because you know how to create role-based access controls. So yeah, more or less for today, I think only this. And in tomorrow's session, we're going to deep dive into these different options. We're trying to add some data, query some data, and also see the consistency part, right? Like I said, we have 5 different consistency, the very important topic for the exam. And I will try to accommodate either 2 or 3 questions at the end of tomorrow's session on CosmosDB, so that you get better understanding what to expect when it comes to certification, right? Thank you so much for your time.